production function and the marginal product of labor. So this is the worksheet that we had to use. And you're asked, first of all, to use this particular production function right here. Oops, right here. All right, fix that, start that again. So this production function right here. So we have values for A naught, we have values for K naught, all right, 27 and 20,000 for those values. So that will go in here, that will go in here. And what we're really looking at then is the relationship between N and Y. So if we know N, all right, we plug an N in, we know what A and K are. We plug an N in, and we've got all the numbers on the right-hand side. We can figure out what Y should be in that case. So you can do this with a calculator, but really what you want to do is you want to use a spreadsheet with a formula. And by doing that, you can automate things in a significant way. So let's take a look at that. Let's share a different screen. Let's bring up an Excel spreadsheet. And if we put those numbers in that spreadsheet, right, there's the 27, 20,000. And if we use this formula, what you'll see is this is what it looks like up here, right, as a formula. So use the tools that you learned back in Econ 206 and other courses that you've taken to simplify your life. If you put that formula in this cell, right, and use these numbers, but use the cells, right, as we have up here, right, C4, right, is the A term. D4 to the 0.3 power D4, right, is this term right here. E4 is N, right, that's this term right here to the 0.7, raised to the 0.7. And when we do that, and we know that already because N is 0, and we're multiplying something by 0, it's going to be 0. So no labor, no output. And then all you have to do is you have to copy that formula down your column. So what I did is I just copied this table, right, out of the JiTT, right? I brought it into a spreadsheet. You could do it by hand and to get this column of Y's, but it'll take you a fair bit longer. But these are the numbers that you get then. All you have to do is once you copy this formula down this column, those numbers populate automatically. Okay? And then, so what do we have at the end of that? Okay. So if we plot Y, real GDP, as a function of N, right, that's the graph that we have on the actual JiTT assignment, right? But before we do that, before we look at that, let me also point out that the column over here is the marginal product of labor. Well, what is the marginal product of labor? If you look in the textbook, right, it's the change in Y when we change N. So for this first number, right, there's nothing in this first cell because there's no change. You can't compare it to anything. But if N goes from 0 to 10, then output goes from 0 to 2,640. So the change in Y is 2,640. The change in N is 10, so it's 2,640 divided by 10, or 264. And you do the same thing for every one of these. I've made it easy because the change in N is 10 in every case, right? So if you take the difference between this row, or this Y and this Y, right, as N goes from 10 to 20, Y goes from 2640 to 4,289, right? And so when we do that, right, it's going to be 1,649, right? That's going to be the difference here. And then divided by 10, 164.9. And again, if you do put a formula in for this one, all you got to do is copy it down the columns and all those numbers will auto-populate. What we want to notice here, though, and we'll just do it numerically for right now. What you want to notice here, though, is that these numbers get small, right? Whereas y gets bigger as n gets bigger for a given level of technology, total factor productivity, and capital, right? The marginal product of labor, those numbers get smaller. So we need to understand what that means economically. So I'm going to go back over to another application, share the screen differently again so I can write on it. So let's go back. Over here. And we're back to where we were before. And we have these numbers filled in now on this table, right? And so the questions were, right, to calculate y and the marginal product of labor, MPN. And let's answer these questions before we do anything else. Why are the values of A and K in the table the same for all levels of N? Because we want to show how does output vary when we change employment or labor for a given level of A, which represents technology and schooling, total factor productivity in the economy, and for a given level of capital. Now, later on, we're going to ask what happens when we change one of those numbers, what happens to the production function, right? The overall level of production in the economy, okay? But we'll get to that in just a little bit. And then how is the last column of the table related to the graph of the production function on page 2? So let's take a look at that. So I'm going to go to, no, let's actually just stay where we were. Let's just scroll up and take a look at that. All right, if we plot those numbers that we had in that in the problem here in the worksheet, as I had in my spreadsheet, but which are the same thing, all right? And we have, I'm going to make this a bigger. So this is the production function for when A is equal to 27, K is equal to 20,000, all right? And we have the N on the horizontal axis. We have Y, real GDP, on the vertical axis. And so you see N can be 10, 20, 30, 40, 50, 60, 70 goes up by 10. And then this is how Y changes. In other words, that first column, how that changes as N changes when A is 27 and K is equal to 20,000. Okay? So what do we see? Well, we see that Y as N gets bigger, Y gets bigger, real GDP gets bigger. That makes sense. Right? If we have more workers working with capital and technology, we get more output. But notice that it's not a straight line. It's not linear, right? Rather, it curves and it tends to get flatter. The slope of this line gets shallower, smaller over time. But what is the slope of that line? Let's think about that. Slope, right? Something we learned in middle school, right? Is in an XY graph, change in Y over change in X. So just not the Y and the X here. So what's on the X axis here? Well, here it's the change in Y. It actually is Y divided by the change in N. N is on the horizontal axis, right? So that's the slope of this line. But notice that that's the what? That's the marginal product of labor. So let's just think about what that means. So what does it mean in terms of the graph? So if N, for example, let's just pick a point. Let's say N, 0 to 10, right? N goes from 0 to 10, right? Goes from there to there. Y goes from 0, right, up to um, whatever it was. Let's look back what it was. We don't have it on this one. I have it on back on my spreadsheet. So let's see if we can. I don't remember exactly what the number was. It's 2,640. Right? It's 2,640. So this is 26. Whoops, sorry. This is my pen. 2640. That's this number right here. So the change in Y is 2640. The change in N is 10. So the change in the slope is just rise over run. All right. We learned that about that back in middle school. All right. And so the change in Y over the change in N is the slope. That is 2640 divided by 10. All right, this is just what we did back on that spreadsheet. That's 264. Right? That's the marginal product of labor. What does that mean in terms of economics? It's the extra output you get with an extra unit of labor. But the only way we can graph this graph or any other graph on 2 dimensions is we got to hold the other things constant. That's why we hold K constant, and we hold A constant. Now, if we increase N by another 10, then output goes up some more, right? This much. And so we take that slope. And then N goes up by 10 more, output goes up to here, right? And we can take that slope. Goes up another 10, right? And we go over 10, and we go up, right? To this point on the production function. Well, what's happening, right, to that slope, right? What's happening to that slope? Well, those numbers that we just calculated on the table, that last column, right, they're getting smaller. So the slope here, right, the slope back here, right, it's put a different color in there now, right? The slope here, right, is like that. The slope here is like that. The slope out here, it's harder to see, but it's getting smaller. It's getting flatter, right? So this is a slope that looks like that. This is a slope that looks like that. This is the slope back here, right? You can make these triangles, rise over run. So what's happening? The slope is getting smaller as employment, labor, as we use more workers. So you get more output, but the amount of output you get from additional workers gets smaller and smaller and smaller. What do we call that? We call that diminishing marginal returns to labor, right? That's what we call that. Okay, so what's happening? The answer is draw your graph of the marginal product of labor. Now we could actually, what we want to do is we want to take the column from our table on the vertical axis and graph that relative to N, right? 10, 20, 30, 40, etc. Right? We know that the marginal product of labor at 10, from what we calculated, is 264. And what we know from doing the calculation on the table is that when we do the marginal product of labor for different levels of employment, different levels of N, right? It's going to look like this. In other words, as N gets bigger, the marginal product of labor gets smaller, all right? As N gets bigger, the marginal product of labor, right, gets smaller. So this is the marginal product of labor for this production function. We could actually plot the actual numbers, and that's what I want to do. But right now, it's important to note that that's what that looks like, right? Now, the other part of the JiTT says, well, what if a different green. Okay. What if K increased to 30, right? This number right here went from 27 to 30. So you just redo that table. In fact, in a spreadsheet, it's really easy. Once you made that first table, you made it in a spreadsheet, you just copy it over to a new sheet, and you just change all the 27s to 30, and everything repopulates in 30 seconds. You have it all back, right? And what you'll see if you plotted the numbers for when K is equal to 30, right? When K is equal to 30, right, rather than 27, that for every N, Y is going to be bigger, right? Except at 0. 0 is going to be the same. So if we plotted all those numbers, we would get something that looked like this. In other words, it doesn't shift up, it tilts up. It doesn't shift up. So it kind of tilts up because it still goes through 0, right? So this is when A is equal to, K naught is equal to 30. This, right, was when K naught is equal to 27. So we increase the amount of capital that workers have to work with, and what happens? Output goes up. That shouldn't be any mystery, right? Mathematically, this gets bigger, that's going to get bigger, right? If A gets bigger, that's going to get bigger, right? So an increase in K, an increase in A is going to shift this production function up. That's part of the purpose of this JiTT, is just to show that at this point, right? So what does that do to the marginal product of labor? Well, when you actually do the calculations in a new table, what you'll see, right, and what you can see here, right, is that the slopes, right, on the green line, whoa, we just lost there, bit of our green line there. Sorry about that. All right. All right. Pardon me. Sorry about that. All right. What you'll see on is that the slopes, right, are, because it's tilted up, right? It's tilted up. So the slopes on the green line at every N are bigger. In other words, the marginal product of labor for every N is bigger when K is equal to 30. Sorry, when A is equal to 30. I had it right when I said it before. K is 20,000. Right? I'm sorry about that. Right? When A or K, either one increases, this the same thing is going to happen, right? Generally, all right? So A equals 27 versus A equals 30, all right? So the slopes are going to be bigger. So this is the marginal product of labor when A equals 27, all right, in that production function. What's going to happen is marginal product of labor for every level of N, NPN prime, is going to be higher. It's going to shift up and to the right, when A is equal to 30. So let's just dissect that for a minute. All right, let's think about the economics. That's the math, right? That's the math. And that's what I'm having to do, a simple mathematical or just algebraic problem, a very specific problem. It's very specific, just with numbers. But I want you to take the takeaway from this should be a broader one. We have a production function. We can show what that looks like. That's that blue line. That's when A equals 27, K equals 20,000. And we a graph that looks like this. They're diminishing marginal returns to labor, right? It's not a straight line. It's a line that flattens out, which means that the marginal product of labor decreases, right? Decreases as N gets bigger. All right, that's that orange line. If we change A or K in this production function, we just hold them constant. But if they change to a new level, right? A new constant level, they stay the same for all different levels of N. In other words, if workers have better technology to work with, or if they have, that would be a change in A, or they have more capital to work with, then that is going to shift the production function up. It's going to increase the marginal product of labor and shift that to the right. It's going to be important because the marginal product of labor is going to get transformed into the labor demand curve. In other words, that's going to increase demand for labor. Why? Because workers are now more productive, either with more capital or with new technology, new education levels, etc. Okay? So this is the JiTT number 3 result, right? Just it was really having you calculate these things so that you could have an actual example. You could see what it looks like. And because going forward, we're not going to do this with calculations. We're going to do it in terms of the general pictures and the general shape of these pictures and what causes the lines to shift. Right? So I think in some cases you may have overthought it a bit. Right? I really just needed you to fill in the table and then graph it and then see what that means. Right? That's really as simple as this example was. The how to do this actually is in chapter 1. It's not the same exact problem, but yes, actually the answer to this and how to do this question is in the first section of chapter 3, I should say, in the book. Right? So go back and look in chapter 3, and you'll be able to apply this to that information in the chapter.